Hey everybody, welcome back to my channel. Today we're going to continue our lesson 8.5 in our chapter about using intercept form with quadratic equations and parabolas. On yesterday's video we started to introduce how sometimes quadratic equations may be written like, I'm just going to make one up here, may be written like this, where it's written in a different format, which we call the intercept form, where you have two parentheses and you have the intercepts or the zeros, the x-intercepts or the zeros right here. Like in this one, the x-intercept would be 2, and on this one, the x-intercept would be -3. It's always the opposite of whatever is in the parentheses. And that's what we looked at yesterday. We looked at how you could use those parentheses to figure out what the x-intercepts were. And then once you had those x-intercepts, you found the midpoint, the point halfway between those, plugged it into the original problem, and that gave you the vertex. Now, today I want to keep building off of that because they won't always write the original function, the original equation, in the format that I just had there at the bottom of my board. You can see all of the kind of example problems I have up here right now. They aren't simplified all the way yet. So what we're going to have to do, we're going to have to go back to, you remember what we did last chapter whenever we would have questions like, oh, I don't know, I'm just going to make some up here, like this, or whenever we had polynomials, remember all of last chapter, and we would have to factor polynomials. And sometimes it was the easy ones like this, whenever the a was 1, like this has an imaginary 1 in front of it right here, you could do it in your head, right? And you asked yourself, what two numbers multiply together to equal 6 that add up to equal 5? All right, it's that type of a question. So we're going to have to factor some of these. Okay, the numbers that multiply together equal 6, that add up to equal 5 are 3 and 2. And you see how now, once I have it factored like this, it kind of looks like the intercept questions that we did yesterday. And then we also had these that were like the difference of two perfect squares, right? Where this is the square root of x squared and the square root of 81, except one was a plus and one was a minus. So that's what we're going to have to do on some of these. We're going to take some of the skills we used last chapter in the polynomials factoring lessons, and we're going to apply those skills to these questions today. So, for example, I've got 5 of them over here, and you can see I'm liking the idea to just use different varieties of k of x, j, h, g. Sometimes I'll just put a y, just so you guys get familiar with the fact that they can do whatever they want, almost basically over here on the left. They can have a y, they can make up whatever letter they want in a parentheses with an x. None of that really affects the way you do the problem, so don't get hung up on that. What we really want to focus on is this right here, right? Because this is not factored yet. I believe this is one of them that I just showed kind of on the example board. This is a difference of two squares, isn't it? Do I know the square root of x squared? Yes. Do I know the square root of 16? Yes. Is this a difference, right? Are they being subtracted? Of course it is. So another way to write this is to say this. The square root of x is, or x squared is x and x. How did they get -16? They did the square root. It had to be 4 and -4. It doesn't matter which one has the +4 and which one has the -4. And now what we have is a factored version of the original equation right here that can tell me the intercepts, right? Or the zeros. Do you remember way back last chapter where we would replace this with a 0? And we would say, okay, what number goes in the first parentheses to make that equal 0? Or what number goes in this parentheses to make this equal 0, right? Whenever we did the zero product property. I'm going to erase that because it's kind of sloppy. It's the same idea that we did last chapter. So it's always the opposite of the way that it looks, right? You put the number 4 in right there to make that parentheses equal 0. And then you would put, it's always the opposite. It's going to be -4 and -4 in this one. So it's always the opposite of the way that it looks in the parentheses, or it's also another way to think of it. It's the same idea, to think of it as the number that you would plug in to make that parentheses equal 0. That's why it's called the 0. So those are our two x-intercepts. From there, I could figure out the rest of it using the same skills that we had yesterday. Remember the skills that we had yesterday? We would try to find, in order to get the vertex, you have to find the midpoint, right? Our zeros are at 4 and -4, and I just kind of freehand a little coordinate plane down here. 1, 2, 3, 4. I make my dot. 1, 2, 3, 4 on the negative side, make my dot. What's halfway in between 4 and -4? It's got to be 0, right? 0, whoops, that shouldn't be a dot. 0 is halfway in between 4 and -4. They're both 4 places away from 0. Let me fix that since I messed it up. So we have our axis of symmetry at x equals 0, because 0 is the midpoint, right? Halfway between 4 and -4. So I know that my parabola is going to have a midpoint right there through that axis of symmetry. And then how do I get the axis of symmetry? Well, I just plug, or how do I get my vertex? Sorry, I'm speaking incorrectly. So I know that it's going to be 0, comma something. I just need to figure out what this something is for my vertex. You do that by putting 0 up here into the original problem. You could also put it over here. It doesn't really matter. If you put 0 right here, it says 0 minus 4 times 0 plus 4. And I believe that would be -4 times +4. -4 times +4 is -16. And so I would have to put it out way, way down here at the bottom at -16. I don't have room. And then I would make my parabola from there. So our domain, all of these are going to have a domain of all real numbers because they go forever and ever to the left and they go forever and ever to the right. The range on this one, remember my point way, way, way down here, if I had room, would be at -16. So my range is going to be, where's this graph located? It's located at -16 and above, because this one is one that goes up like that. So it's going to be greater than or equal to -16 on the y-axis. Okay, that was the first one. I kind of made a few little hiccups there. Let me see if I can improve myself a little bit on the second one. Really the only thing that's new today compared to what we did yesterday is today we're going to have to factor these equations at the very beginning. Once we get that first step done, once you can rewrite it as a factored version of itself, it's exactly the same thing that we did yesterday. So let's look at the second one. Now this is not a difference of two perfect squares. I mean, this is a perfect square, but this is not. There's no square root of 5 or 5x. But what I do notice is they have something in common, right? They have a GCF. Is there something that both of these have that I could take away? And I think there is, right? They both have a letter x. So if I factored this, let me write it up here. If I factored it, I could take an x off of both of those. If I take the x off of both of those, what's left? X squared, if I take one x away, it's just going to be x. The -5x, if I take one x away, it's just going to be -5. Remember whenever we factored polynomials last chapter? It's the same idea. Now, what are my zeros? What are my zeros? My zeros are right here, right? It's always the opposite. -5 is actually 5 to the right. That's another way of saying what number, if you plugged it in here, would make this parentheses equal 0, right? Remember whenever we had this in last chapter? Get my hand out of the way. We would say, okay, since our final answer is 0, one of these two had to equal 0. And what number would make the first parentheses, or make this parentheses equal 0? 5, because 5 minus 5 would equal 0. Or another way to think of it is, what would that have to equal to make the whole thing equal 0? It could be 0, right? And so if they give it to you in a parentheses, just like yesterday, it's always going to be the opposite, right? -5 is actually 5 to the right, or the number 5 is what you would plug in here to make this equal 0. If it's not a parentheses, if it's just a regular letter x, then you just call it 0, right? And so what that means is this parabola has x-intercepts at 0, which is the origin, obviously, and 5. So it's going to have a point right here at 0. It's going to have a point right here at 5. And then if I wanted to find the axis of symmetry, I'm going to find what is halfway in between 0 and 5. Now, most people know in their head what's halfway between 0 and 5. Most of you know that, right? 2.5 or 2.5. If you didn't know that, you could add them up and divide by 2. Add those up and divide by 2. And then once we get the axis of symmetry, we can take the axis of symmetry and plug it into our statement in the spot of the x. So I could put 2.5 right here and for the x. I kind of like putting it up here just because that's a little bit easier. If I put 2.5 right here, and then I put 2.5 right here, both of these spots where the x is, right? Do you see how I just copied this down, except I just put a 2.5 in the spot of the x? And so if I work this out, let me go ahead and erase that because I don't need that anymore. That would be 2.5 times whatever the second parentheses is. 2.5 minus 5 would be negative 2.5. And so what I really have is 2.5 times negative 2.5, which I believe is negative 6.25. But just to make sure, I'll go ahead and try it on here. 2.5 times negative 2.5. Yes, negative 6.25. And so that means our vertex is going to be, the vertex is always going to start with your x axis of symmetry, and then it's going to have the answer we just got as the y coordinate, right? So those two are always the same. And so this means I would go all the way down to negative 6.25, way down here, which I don't have it on camera, but I would have to go way down to negative 6.25. I didn't have space to get there, and then I would make my parabola like that. The domain, all real numbers, because this graph goes forever and ever to the left, it goes forever and ever to the right. The range, this thing has a low point of negative 6.25, and then it goes above. So greater than or equal to negative 6.25, right? So that is number 2. Okay, let's erase this, and we'll look at number 3. Clear out all my stuff here. All right, number 3. This one is a little bit easier, I think. This is one of the factoring ones again. This is obviously not factored, but what I do notice, this is actually written in the form that we had at the beginning of the chapter. If I'm being 100% honest with you, we could do this one using the skills that we had at the beginning of the chapter. Do you remember how we had this? Whoa, throwing my marker. Do you remember how we had this at the beginning of the chapter? I mean, this is exactly what we have on this one as well, right? Our A is 1. I know that this is going to have a y-intercept of 12 because the C is the y-intercept. And then you know how we had the axis of symmetry formula? You could do this, the negative b over 2a, to get your axis of symmetry. Like we could do negative 7 over 2 times 1, right? And I bet our axis of symmetry is going to be this. I bet this is going to be the answer. So we could use the skills we actually had at the beginning of the chapter, but for some reason they want us to do this one with the intercept form. I don't really know why. But if you did want to do this with the intercept form and you don't really like doing it the way we did at the beginning of the chapter, you could factor this, couldn't you? Do you know 2 numbers that would multiply to equal positive 12 that would add up to equal 7? 2 numbers that multiply to equal 12 that add up to equal 7. Isn't that 3 and 4? Right? 3 times 4 equals 12, and 3 minus 4 equals, 3 plus 4 equals 7. So I could also have written this formula, this quadratic equation like that. G of x equals x plus 3 times x plus 4. And so if it looks like this, we could say, okay, the plus 3 actually means 3 to the left, negative 3. And the plus 4 right here actually means 4 to the left. So our zeros are negative 3 and negative 4. Our x-intercepts are negative 3 and negative 4. And then we could find what's halfway in between negative 3 and negative 4. And oh wait, look, it is this. It's negative 3.5. What's halfway in between negative 3 and negative 4? It's negative 3.5. And that is our axis of symmetry. That's also the first part of our vertex. That's the x-coordinate in our vertex. And if I want to find the y-coordinate, I would just take negative 3.5 and substitute it in our parentheses, or right here, substitute it in for the spot of the x. So if I do substitute it in here, this would say negative 3.5 plus 3, And in the second parentheses, it would say negative 3.5 plus 4. Right? And I can solve that. Negative 3.5 plus 3, isn't that negative 0.5? And isn't this second one negative 3.5 plus 4? Isn't that positive 0.5? I think. You could use a calculator to check. And so I would have negative 0.5 times positive 0.5. I think that's negative 0.25, but I just want to double check. Negative 0.5 times positive 0.5. Yeah, it's negative 0.25. And so that means negative 0.25 or negative 1/4 is my second part of my vertex. So I could technically graph this, right? If I really wanted to, I could make my coordinate plane. I already have at the very top there, I've identified my zeros as negative 3 and negative 4. And then I've got a point here. Let me go ahead and make a few more spots on my graph just to have it labeled. So I have the x-intercepts at negative 3 and negative 4. That would be right here, negative 3, and right here, negative 4. Our axis of symmetry is at negative 3.5, so like our midpoint is going to be like right up and down through here. And then our vertex is at negative 3.5, negative 0.25, so like barely even like right there. This one is very, only 0.25. It doesn't go down very far at all. So the domain is all real numbers because it goes forever and ever to the right. It goes forever and ever to the left. The range is where this graph is. It's at 0.25, negative 0.25, and above. So on the y-axis, we are greater than or equal to negative 1/4 or negative 0.25. Okay, how am I doing? Oh, 17 minutes. All right, I have 2 more. And then I probably need to wrap it up. Uh-oh, I didn't want to erase all that. Whatever. I can make it work. Last 2. We're just going to keep practicing this factoring, right? This is basically a lesson in practicing your factoring skills. So on this one, let's see, I don't recognize it as a perfect square because 3 isn't a perfect square, 45 isn't a perfect square. It's not one I can do in my head because we have negative 3 as our letter A. What I do know is that all these have a greatest common factor, right? Is there something that I can divide all of those by? I think all those numbers go into 3. And to be honest, it should be negative 3. See how whenever it starts with a negative, do you remember that from last chapter? When your letter A starts with a negative, you always factor it out. You don't ever have a negative whenever you're factoring as your letter A. So I'm going to divide everything by negative 3. So negative 3x squared divided by negative 3 is just going to be x squared or 1x squared. Positive 6x divided by negative 3 is going to be minus 2x. And then 45 divided by negative 3 is negative 15. And so I can actually break this down a little bit, can't I? Do I know 2 numbers? Because now it's in a format I can do in my head, right? This is, the letter A is 1 here. I can do this in my head. Do I know 2 numbers that multiply together to equal negative 15 that add up to equal negative 2? I think I do, right? Isn't that negative 5 and positive 3? Does negative 5 times positive 3 equal negative 15? Yes. Does negative 5 plus 3 equal negative 2? Yes. So there you go. Now I have this as my, right here is my function written in intercept form. I have it factored all the way. And this tells me almost everything that I need, right? It tells me that my zeros or my x-intercepts, my zeros are at 5, right? It's not negative 5, actually means 5 to the right. And this plus 3 actually means 3 to the left. So my zeros are at 5 and negative 3. My axis of symmetry would be what's the midpoint? What's halfway in between positive 5 and negative 3? I don't know. If you don't know, just add them up and divide by 2. Positive 5 plus negative 3, and then divide it by 2. Sorry about that. 5 plus negative 3 is 2. 2 divided by 2 is 1. So my axis of symmetry is at x equals 1. And then if I want to find the vertex, I know it's going to have 1 at the beginning because it's the answer I just found. And then I need to take 1 and plug it in right here and here in the spot of the letter X. So I would have negative 3 times 1 minus 5. 1 minus 5 would be negative 4. And 1 plus 3 would be positive 4. So I would have negative 3 times negative 4, that's 12. 12 times 4 is 48. So this would have a vertex of 1 and 48. And then this is going to have a domain of all real numbers. It would have a range, because this one opens down. You see how it starts with a negative. The range on this one would be y less than or equal to 48, because this is always the number you use when you do the range. Okay, we have one more. Let's see if we can knock out this last one. Oh, you know what? This is going to be an interesting one. I don't know if I intended for this one to be on here like this. Okay, we can do it though. X times x squared minus 9. This is a 9. It kind of got cut off down here. Isn't this right here, this parentheses, a perfect squared? Isn't that a difference of two squares, right? Isn't x squared minus 9 something that I know the square root of both of those? Can I break that down? Of course you can, right? Do we know how they came up with x squared? Well, yeah, they did x times x. Do we know how they got 9? Since this is a perfect square and this is a perfect square, the only way they could get 9 is to do 3 times negative 3. And look at what we have on this one. This is actually factored now. We haven't seen one like this at all. And honestly, I don't even think this is a thing we need to know in Algebra 1, at least in Missouri. But I'll show it to you anyway, just because it's kind of cool. We have, if I go back, what are our zeros? And put this back up here. What are our X-Intercepts? Right? What are those? Well, it's always the opposite of what it looks like in here, right? Instead of negative 3, that means 3 to the right. So we have one at 3. Right here, positive 3 actually means 3 to the left. That means negative 3. But oh wait, here's a new one we've never seen before. We've never seen just a regular x out here by itself. When it's just a regular x all out here by itself, that is actually 0, right? And so this graph is a graph we've never seen before. Let me go ahead and put it on here just to make it really visible for you guys. We've never seen one like this before. This graph has 3 x-intercepts. It touches at 3. It touches at negative 3. It touches at 0. Oh my goodness. This is not a parabola anymore, right? This is going to be a cubic function, right? This is not quadratic. It has 3 x-intercepts. There is no axis of symmetry on this one. There is still a domain and range, but really, how do you graph this one? Well, you would have to pick a point. I need to figure out where this graph is, like in the middle here. So like you can pick this point, which is 1, or this point, which is 2, and then just like, do one of these old school X and Y tables. And then we might want to know where it is here and where it is here, negative 1 and negative 2. And we can just take these numbers and plug them into our problem, right? Like if I put the number 1 right here, if I took the number 1 and plugged it in for x here, here, and here, I would have 1 times 1 plus 3 is 4, and then 1 minus 3 is negative 2, and that would be 4 times negative 2, negative 8. Then if I put 2 in here, it would say 2 times 2 plus 3 is 5, 2 minus 3 is negative 1. That would be 10 times negative 1. And then if I put negative 1 in here, let me erase these so it doesn't confuse you. If I took negative 1 and substituted it in, it would say negative 1 times negative 1 plus 3 is 2. Negative 1 minus 3 is negative 4. And that would equal positive 8. And then for the last one, I would put negative 2 in here for the x. And that would be negative 2 times, let's see, negative 2 plus 3. That's 1. Negative 2 minus 3. That's negative 5, and you would get positive 10. And if you graphed this, and I didn't make my graph tall enough because I need to make it go to 8. Whoa, sorry about that. Let me fix my camera. If I need to make my graph go to 8 and 10, what you would see is this actually, like negative 8 would be way down here. Negative 10 would be even further. it'd be down like this, and then this would be positive 8, and this would be positive 10. This graph actually goes something like this, right? I didn't make that. It should be more curved than what I drew it as. It makes looks kind of like one of those heart rate EKG machine things, right? It makes more of a curve like this, right? And the reason this one does it this way and it doesn't look like the others is because if you look way back at the original problem before I erased it, if I said, hey guys, what does this actually equal? Right? If you distributed this, look what you actually would have. If you distributed this way back at the beginning, you would have had this, right? And you would have something to the third power. And when you know something is to the third power, it's what we call cubic, and cubic graphs always look like these, right? They're always going to have almost this up and down, something completely different than what we've seen on all the other questions. So I apologize about that one. That's really not part of our class. It is in our book. I can show you some more about those tomorrow if you really want to, but it's technically not part of our lesson. So I think I'm going to stop right there because I'm at 26 minutes. So I will give you guys some more questions today. Really, it's the same thing as yesterday with the small exception that you have to factor at the very beginning, right? You're going to have to take the original function and factor it, either by, doing the greatest common factor, what do they all have in common, or by factoring in your head what two numbers multiply together to equal this, that add up to equal this, or by looking for a difference of two squares, something like that. So I hope you all do well on it. If you do have trouble, feel free to use this video as you work through them as your guide, or email me and I'll be more than happy to help you. Thank you so much.